Money, 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 money. Check out all my money. I got some red ones and some white ones. You know what? Those are just stacks of fake money, aren't they? Maybe chips. But hey, you notice anything about them? It's doubling each time. We got 6, then we got 3, then we got 6, then we got 12. That's actually growing exponentially, which is what we're going to be talking about today. Geometric sequences, which are things that sequences that grow exponentially, or they multiply. So two things for today. We're going to determine if a sequence is a geometric sequence, and then we're also going to be able to find any term in a geometric sequence. For instance, if we know there's a sequence and we want to find the 100th term, we can find it using a simple formula. So let's start with what it is. A sequence, just a regular sequence, is a sequence, is a set of things, usually numbers, that are in order. So this is just a regular sequence. All right, here's an example. 3, 5, 7, 9. You might see the pattern. If it kept going, this would be 11, 13. It's just every other number starting with 3. Now, the first number in our sequence is always going to be the first term. That's going to be important for what we're going to for our formula that we're going to use. Those 3 dots, they just means it goes on forever. It's also called an ellipsis. I might spell this wrong, but it's an ellipsis. All right. And then each number is called a term. Now this type of sequence is different, you might notice. It goes 2, 4, 8, 16, 32, 64. Can you tell a difference? In our first sequence, we were adding 2 every time. Plus 2, plus 2, plus 2, and you got to the next one. This time we're not adding. This time it is multiplying. So this is times 2 to get to 4. Times 2. Times 2. So a sequence when you're multiplying is a geometric sequence. So in a geometric sequence, each term is found by, so this is important for writing down, each term is found by multiplying the previous term by a constant. So every time you're multiplying by the same term. And that term is called the common ratio. I'm going to write that in here. Let's make sure we write that. Called the common ratio. All right. Now, we... Oh, here's an example. Our example, which we had above, the sequence is a factor or common ratio. So we're going to say our factor of 2, a common ratio between each number. So it starts with 2, and it also multiplies every time by 2. Each term except the first term is found by multiplying the previous term by 2. So, how can we determine if something is a geometric sequence? So in this case, we're going to determine if a sequence is geometric. If it is, we're going to also find the common ratio, meaning, I'm going to put in parentheses again, what you multiply by. So which of the following ones are geometric sequence? Let's actually go in order here. First one, we got 3, 6, 12, 24, 48. So it's got to be a sequence where you multiply by something each time. So if we start at 3, to get to 6, we'd have to multiply by 2. So 6 to 12, we would also multiply by 2. 12 to 24, we'd multiply by 2. 24 to 48, we'd multiply by 2. So every time it is multiplying by 2, our common ratio, which we're going to say is R, so yes, and our common ratio is 2. All right, 3, 6, 9, 12, 15. So we've got a sequence here. There's definitely a pattern to it. I can't find a number that you'd multiply each time because we could go 3 to 6, we'd multiply by 2, but 6 to 9, we would not be multiplying by 2. So it is a sequence, but no, it's not a geometric sequence. All right, B. 1/3, 1/9, 1/27th, 1/81st. So there's definitely a pattern, I think. Um, in this case, it seems like you're multiplying by three, but really, to get to from 1/3 to 1/9, we'd actually have to multiply by 1/3. 1/3 times 1/3 would be 1/9. So to get from 1/9 to 1/21st, we'd multiply by, again, 1/3. So this one is, every time it does work, it is a geometric sequence, and the common ratio is 1/3. All right, D, 4, 7, 11, 16, 22. I don't even know if it's a ratio. Well, maybe it is. I don't think you can multiply by it, but it goes up by plus 3, plus 4, plus 5, plus 6. Okay, it's adding something, one extra each time, but it's not geometric. All right. So those are examples. That's taking a look at and figuring out if a sequence is geometric sequence or not. It has to have a common ratio that you multiply by. That's the key thing. All right, the second learning target we wanted to focus on was finding any term. So there is a formula, and it's pretty sweet. To find any term in a rule, like our examples before, we could find like the 100th term. We can use this formula. So let's break it down. This formula is actually not as hard as it might look. Um, so a to the n. This is a little it's not an exponent. It's not above. It's below. This right here is just another way of saying which term are we trying to find. Okay. So the n, whatever is in place of the n is going to be telling us which term. So um, in this first one, this first part of our formula, you're going to plug in the first term. So a sub 1, meaning the first term is we're going to put in the first term. The r is our common ratio, whatever we're multiplying by each time. That does not look like the word common. I don't know why. Got so messy. There you go. And then we plug in for n whatever the term we're trying to find. So if you want to pause this for a second and make sure you have this formula with the descriptions in here, it'll help you a lot with the rest of it. All right, and the more you do, the more it'll just make sense. So this first example, it says find the x to the so 22. So instead of an a, it's an x. It's the same idea. We just need to find the 22nd term. So in our formula, our first term goes in front, and our first term is given here as 1. So it's 1 times r, so our ratio is 2, to the n minus 1. So n is 22, so 22 minus 1. So really, we're just going to raise 2 to the 21st power. So we're going to do 1 times 2 to the 21st power. Um, let's see what you get when you type in 2 to the 21st power, because we always got to do exponents before multiplying. 2 raised to, so we're going to use our little, oh, where is it? Where's the little caret? On my calculator, I have to push this button right here, this X with the N. And the 22nd power is 4. Oh, lost it. 4,194,304. 4,194,304. So instead of taking my sequence and starting at 1 and going up by 2 every, or times 2 every time, 1 times 2 would be 2. We could figure that out. The common ratio is 2, so you multiply by 2, and you multiply by 2 again, multiply by 2 again. That's what the sequence would look like. The 22nd term would be 4,194. Oh, I might have actually did it too many times. I had to do it to the 21st power. 2 to the 21st power. There you go. Smaller number. 2,097,000. 2,097,152. Still a pretty large number though. That's the 22nd term in this ratio in this sequence. Give you a couple more here. X to the 10th. So in other words, find the 22nd or the 10th term. Okay. This one we're just given the sequence, so you got to figure out what the first term and what the ratio are. So the first term, e to the first power is going to be 3. That's our first term. So we know when we're plugging in x to the 10th, we're going to do 3. Now we got to multiply it by the ratio. So let's see. To get from 3 to 12, you multiply by 4. To get from 12 to 48, you multiply by 4. So it looks like we're multiplying by 4 every time, so our common ratio, R, is 4. So let's plug in 4 and raise it to the 10 minus 1 power, which will be the 9th power. So we're going to do 3 times 4 to the 9th power. So I first got to do 4 to the 9th power. So you're 4 raised to the 9th power. And then I got to also multiply by 3. And I get 786,432. 786,432. That is the 10th term of this sequence. Why don't you pause it and try this last one on your own? Alright, so for this one, our first term is 1. Our common ratio, if I go up, this is definitely multiplying by 5. This is definitely multiplying by 5. So we're multiplying by 5 every time. So our common ratio is 5. Alright. Now plug it in for this. If we're still finding the x term in this one, sorry, the 10th term. First term is 1. Common ratio is 5. Raised to the 10 minus 1 power. So I'd be doing 1 times 5 to the 9th power. And multiplying by 1 doesn't do anything. So really we're just doing 5 to the 9th power. 5 to the 9th power is that big long number. Looks like it's 1,953,000. 1,953,125. That's the 10th term in this sequence. Sure wouldn't have to multiply it out over and over again to get that number. But 10th really isn't that bad. If you get to the 100th term or something like that, it'll take a long time to do it without this formula. So that's how we find any term in a sequence using a formula. So make sure you have that formula in your notes. Make sure you understand what a geometric sequence is and how to determine what it is. Those are our 2 goals for today. And yeah, we're back to all my money, money, money. But really, it was just showing that it's going to be multiplying by 2 every time to get bigger and bigger. That's our lesson, 413. Enjoy the rest of your day.